Hi my friends, this tool you see in front of you is called a multimeter. This device is very useful while dealing with measuring electronic stuffs. It always has two pins, the black pin and also the red pin. Here is its power button, so let's turn it on. This type can measure a variety of electronic units like capacitance, current, here alternating current, here direct current, and also resistance, as you can see on the scale here, direct current and alternating voltage, plus a constant called HFE. It also has a feature that measures continuity. Here it is, but in order to understand it better, let's do out some various measurements with it. As a first test, I have a resistor of unknown resistance I want to measure, so I use the resistance scale here. Just set it to a higher resistance knob, and it is measuring 6.84, so the resistor is 6.8 kilo ohms. As a second measurement, I want to measure the voltage contained in this battery. This battery is unlabeled, as you can see, so we don't know its voltage. It has two wires, so I want to measure its voltage, so I have to turn the knob to a voltage scale. I connect the minus wire to the minus wire and the plus wire to the plus, so it is measuring 2.5. So this battery has a voltage of around 2.5 volts. Now let's measure the capacitance of this 22 microfarad electrolytic capacitor. In order to measure it accurately, I soldered two wires across its terminals. Set the knob to the capacitance scale. Here the capacitance scale is labeled as F because F is measured in farads and capacitance is measured in farads. After fixing the wires into the holes, the multimeter reads a capacitance of 21.3 microfarads, which is very close to the labeled value. As the next test, I want to measure current using this device. In order to do this, I have a 9-volt power supply that I laying around with and a DC motor from an old DVD drive. I inserted the power supply from the main socket. The motor is connected in this configuration. The two other wires are left for the multimeter to be connected in order to measure the current flowing through this motor. The red knob is changed to the hole responsible for measuring current. Current to be measured runs through the multimeter and is displayed on the LCD screen. When the motor starts spinning, the current flowing through the motor is displayed on the screen as 0.4 milliamps. Another task is to measure the constant of a transistor, HFE. This is the 2N222 NPN transistor. Simply insert the NPN transistor into the corresponding hole. The constant HFE displays instantly. As the next test, I'm going to measure voltage from the mains extension. Before doing this, you have to be careful with the integrity of the probes you are using, as any mistake will cause the device to blow up or even shock you, because main voltage are too dangerous and can kill you. With the knobs in the proper position, insert them into the power lines and measure the alternating voltage. The alternating voltage here in the multimeter shows a voltage of 237 volts AC, which is very close to the rated 240 volts AC. Last but not least, I'm going to measure the continuity of a wire using this device. Continuity means there is almost zero resistance across a conductor. When a conductor does so, the multimeter responds using a beeping sound indicating the wire is not cut, or simply the wire can conduct electricity without any fault. In order to do this, I connected across the ends of the wire in order to hear the beeping sound from the multimeter. And if simply the wire just happens to break in the middle, or simply you just cut it, the beeping stops, indicating that the current cannot flow and the wire is faulty and cannot transmit electricity. So the beeping disappears completely. Okay guys, I hope you learned something new. If so, don't forget to like and subscribe. That will be awesome and I'll be so thankful. Thank you for watching.